Hi, everyone, and welcome to this first lesson on Chapter 1, Section 1, titled The Scope of Chemistry. A great way, to listen to these recordings is to probably read through this section first in your textbook and then watch this video recording of my lecture. And then feel free, I also posted the PowerPoints of this in your Moodle page. So you could kind of read through the textbook, watch my video, and then use the PowerPoints if you need to review them on your own as well. So it's great to have you guys here. This first couple section is just kind of helps with a little bit of an introduction to this course. So we'll talk a little bit about this section and what chemistry is. So what is chemistry? It is the study of the composition of matter and the changes that matter undergoes. So chemistry is the study of all of the matter around us, from the desk that you're sitting in to the computer screen that you're looking at, and then how that matter changes. So this matter that makes up all the things around us is made up of teeny tiny atoms. It also answers many questions you may have about the world we live in. So chemistry is kind of the way that we try to answer questions about the world we live in and the processes that occur, like photosynthesis or digestion in the body. Obviously, as Christians, we know that God has designed us and created us all, but chemistry helps to answer these questions. Chemistry includes all aspects of life and most natural events because all living and non-living things are made up of matter. So what is matter? Matter is anything that has mass and occupies space, like trees, water, buildings, and people. So that is what matter is, anything that has a mass and occupies space. And then what makes up this matter are all of the elements and compounds and atoms that we'll talk about. We have 5 traditional areas of study in chemistry, and you should spend some time being familiar with these and being able to explain each of these 5. So I'll list them for you, and then we'll go over them one by one. We have organic chemistry, inorganic chemistry, biochemistry, which is one of my favorite, analytical chemistry, and physical chemistry. So let's go over these one at a time. So organic chemistry is defined as the study of all chemicals containing the atom carbon. And most chemicals found in organisms contain carbon. So an organic chemist might develop new lightweight plastics for flying discs. So a lot of times organic chemists are kind of the building chemists. They create new molecules and they understand how molecules work. But organic chemistry specifically is the study of all chemicals containing carbon. So if you can kind of combine in your head organic chemistry and carbon, that will help you remember that one. The next area of study that we have is inorganic chemistry. Inorganic chemistry is the study of chemicals that in general do not contain carbon, and many inorganic chemicals are found in non-living things like rocks. An inorganic chemist, for example, might develop metal materials that provide very strong structural parts for buildings. So that is organic chemistry. Then biochemistry, I mentioned that biochemistry is one of my favorite because it has to do with the processes that take place in living organisms. So biochemistry would help to explain how our muscles contract, how digestion occurs in the body. And a biochemist might study how the energy is used for the contraction of muscles and then how it is produced and stored. So that is biochemistry. The next area of study we have is analytical chemistry. And this is the study that focuses on the composition of matter. So analytical chemistry kind of gets into the details of what makes up matter. So this could be measuring the level of carbon dioxide in the atmosphere, and an analytical chemist might test the air for the presence of pollutants. So that's analytical chemistry. The last area of chemistry in our study is physical chemistry, which is the area that deals with the mechanism, rate, and energy transfer that occurs when matter undergoes a change. So a physical chemist might study the factors that affect the rate of photosynthesis in trees, for example. So that's physical chemistry. The lines between those 5 areas of study in chemistry are not totally set in stone. Sometimes they overlap. For example, a chemist might use one area of chemistry at any given time on their project. So for one aspect, they might be looking at the analytical parts of it. How does this composition or make up the matter? Then they might use some aspects of physical or inorganic chemistry. So a chemist might use more than one area of chemistry at any time in their project. An organic chemist, for example, might use analytical chemistry to determine the composition of their organic compound that's made of carbon, for example. Then we'll talk a little bit about in the areas of study, we can have pure chemistry or we can have applied chemistry. Pure chemistry, for example, is the pursuit of chemical knowledge for its own sake. So it's a scientist just being interested in a problem and trying to solve it for the sake of just understanding. That is pure chemistry, the pursuit of chemical knowledge for its own sake. The chemist doesn't necessarily expect that there will be any immediate practical use for that knowledge. So that is pure chemistry. So for example, the synthesis of nylon and the synthesis of aspirin, at first, chemists were just trying to understand how we could create nylon or aspirin, not necessarily knowing yet the implications or applications for those yet. And then applied chemistry is research that is actually directed towards a practical goal or application. So the chemist would be trying to solve a real world problem that would have direct effects on either people or things. So for example, the cure for a disease or making a product better, that would actually be applied chemistry. Then we'll go through kind of some big ideas in chemistry. The big ideas in chemistry is that chemistry as this kind of central science that ties all other sciences and maths together. We talk about it, math as the language of the sciences. And we talk about chemistry as kind of the interpretation of the sciences. We'll talk about electrons and the structure of atoms. We'll talk about bonding and interactions between those atoms. We'll talk about reactions and what that means. And then we'll talk about the kinetic theory, which is particles in motion. We'll talk about the mole and quantifying matter, how we can kind of analyze and quantify the elements that make up matter. And then we'll talk about how matter and energy are connected. So these big ideas in chemistry are listed for you. And now we'll go through kind of each one individually for the remainder of this lesson. And we'll end with carbon chemistry. So big ideas in chemistry. Chemistry as our central science. Chemistry overlaps with all other sciences. So for example, many physicists, biologists, astronomers who study the stars, geologists who study rocks, and environmental scientists, as well as others, will use concepts of chemistry in their work. And that's because matter is made up of these elements. And that's what the study of chemistry is. But whether you're a biologist, astronomer, or a geologist, you're always all studying matter. So you have to have an understanding of chemistry to do that. The second big idea in chemistry is this idea of electrons and the structures of atoms. So carbon, oxygen, and copper, for example, are all examples of elements that are found in the periodic table that we will talk about. And all of these elements are composed of particles called atoms. And every atom contains a nucleus and one or more electron. So this idea of electrons and the structure of atoms will form a foundation for our study of chemistry. So that's why it's one of the big ideas in chemistry. The type of products obtained in a chemical reaction will largely be determined by how their electrons interact in the reacting chemicals. Our next big idea in chemistry is bonding and interactions. And I don't expect you guys to understand this yet. These are just kind of presenting to you these big ideas in chemistry. And then during the semester, we'll go over these big ideas. So most chemicals exist in chemical compounds, which are collections of 2 or more elements that are held together by a relatively strong attractive force. And that force that holds 2 elements together is called a chemical bond. And that greatly influences the property of the compounds. For example, if we have a very weak bond that can be broken easily between two particles of an element or a compound, that can also contribute to the properties of that material. So whether we have a really weak bond or a very strong bond, that directly affects what this material looks like. Our next big idea in chemistry is reactions. So chemical reactions involve processes in which reactants produce a product. Think of being in your kitchen and taking ingredients and turning it into a delicious meal. That's what a chemical reaction is. The reactants are the ingredients, which is what you start with, and then the products will be the delicious meal that you create. Obviously, we're not going to be eating these chemical reactions, but that similar idea of taking some ingredients and forming a meal or a baked item. In chemistry, chemical reactions involve reactants, things you start with. They go through this chemical process to create a product, which is what you end with. An example that we give you is when you strike a match, the compounds at the tip of the match or the head of the match will combine with oxygen in the air to produce a flame. The new compounds, along with light and heat, are formed, and the compounds in the match head combining with oxygen will be the reactants, and then the new compounds that are formed, like light and heat, are the products. So that's an example of a chemical reaction, and that occurs all around us. It occurs in your body all the time. So that's another big idea in chemistry. And the next big idea will be the kinetic theory. Kinetics mean movement. So the kinetic theory describes how the particles of matter are in constant motion. This means the particles that are making up the matter in your coffee mug or your bottle of water, the particles that are making up the desk that you're sitting in are in constant motion. And that's called the kinetic theory. And we'll learn how that works. The ways in which these motions vary with changes in temperature and in pressure will determine whether a substance is a solid, a liquid, or a gas. The next big idea in chemistry we have is the mole and the quantifying matter. So whenever we conduct a chemical reaction, you need to know just the right amount of the reacting material so that none is wasted. So how can we determine how much reacting material we start with? This precise measurement is possible using the mole, which is the chemist's invaluable unit for specifying the amount of material in these elements of matter. And we'll talk a lot about moles. Another big idea in chemistry is matter and energy. So every chemical process will use and produce energy, often in the form of heat. And the heat changes that occur in chemical reactions are very easy to measure. So changes in a quantity called free energy allow you to predict whether that chemical reaction will actually occur under the specific given conditions that exist. And our final big idea in chemistry is called carbon chemistry. So we have about 10 million carbon-containing compounds in the world, with new ones being prepared each day. And many of these compounds include plastics and synthetic fibers that are man-made, and they are produced from petroleum. And carbon compounds are the basis of life in all living organisms. And we'll talk a lot about that when we get to biochemistry. So those are the big ideas in chemistry. This is the end of our first lesson 1.1. Again, a great way to kind of work your way through this material is to read the lesson in your textbook, watch my lecture video, look at your PowerPoints to kind of get a good overview of the material for each lesson. Thank you for listening, and we'll see you for the next lesson.